Hello everyone, let's solve some Leetcode today. So today we have Leetcode 101, that is Symmetric Tree. In this problem we have been given a root of the tree and we have to check whether the tree is actually a mirror of itself or not. So this problem can also be called mirror tree problem. In this problem we will have a node and we have to figure out whether this left subtree and this right subtree are invert of each other or not. As we can see here that we have 2 here and 2 here. But then we have 3 here but 4 here. So the left child of 2 is 3 here and the left child of 2 is 4 here. In the same way, the right child of 2 here is 4 and the right child of 2 here is 3. Basically what we did is we took the child nodes and we reversed them. So that is exactly what we have to check, whether these particular trees are invert of each other or not. Now this problem becomes really easy to solve if you have solved the invert tree and same tree problems. So if you would have solved the invert tree problem in the past, you would know what exactly we need to do in this particular problem, that is check whether these two trees are invert of each other or not. And if you have solved the same tree problem, you would know how to actually put DFS or BFS on two trees at the same time. And then you can decide what you want to do in DFS and BFS logic. But let's figure it out from scratch ourselves. On observation, we can clearly see that the first node in a tree is always a single node. There is nothing here or here to compare it to, right? We do have trees, right subtrees and left subtrees, but they will be considered in the next DFS call, not in the current one. So we can always skip the root node and we can directly take this left subtree and this right subtree and put them in the DFS. So once you have access to these two nodes in the DFS, you can check is their value equal to each other. Value 1 is equals to value 2. If it is equal, then great. We know that the tree is symmetric till here. So after observation, we could see that this particular node should be equal to this particular node and this particular node should be equal to this particular node. So in the next DFS call, we will send the left node of this particular tree, left subtree, and we will send the right node of this particular right subtree. So in this particular DFS tree, we will again check the values with this help of base case, whether these two values are equal or not. If they are equal, then again we will take the left of this and right of this. But eventually we will reach a point where we will have a leaf, and from there we can start returning. If both of them are null, we can simply return. If one of them is null, we know that we found asymmetry. If one of them is null, it means that there is some structural deformity. We will understand what that structural deformity is later on, but we can say that okay, it's not a symmetric tree at that point, and then we will return. Once we keep on returning here, so suppose that we came back here to this particular layer. After that we will have to check these parts should be equal to. So we will again call a DFS. So we have this DFS now. This DFS will be called or executed for this particular branch of the DFS. So we can have a global variable res equals to true first. During the execution of the DFS function, if we ever encounter a condition where we know that this particular tree is not symmetric, we will send it to false. And at the end of the code, we will simply return res. That will simply be our answer. Let us understand the flow of DFS that will happen for this tree. So first of all, we will add this particular node. We will simply ignore it. We are not going to pass it in the DFS because it is a single node. We will take these two. We will pass them in the DFS. Now once we have these, we will check whether they are equal. Yes, they are equal. So I will simply move on. I will say, okay, go to the left node of this particular two and the right node of this particular two. They should be equal. We check, okay, these two are also equal. Great. We can now move on. Now I can go to this left node and this right node. Now both of them are none. So I will simply return. There is nothing to do. Now after that, for this particular node, I will check these branches, the right node of this particular tree and the left node of this. So I see again, it is none. So again, we go back to this node because there is nothing to do. We figured out that we have completely analyzed this node. So we can simply go back. I came back to this particular node again. So now we can go to the other path, that is the right node of left subtree and the left node of right subtree. I see that, okay, these two are equal. Great. We are going great. It means till now we have a symmetric tree. So on this particular node also, first we will take the left node of this node and the right node of this node, because that's how our DFS calls are happening in the function. So again, this is none and this is going to be none. So we can simply return nothing to do here. And then again, we will check this branch and then we will find that it is also none. So then we will again return because there is nothing to do here. We will then return back to 2. And now we have completed the DFS because this is where we actually started on these two nodes. This one was skipped. We don't need to check it. It is always going to be single. So it will always be an inversion of itself anyways. So here we did not encounter any condition condition where we need to set our global variable res as false, which means this is a symmetric tree and we can simply return true here. Now let us look at the flow for another tree which is not going to be symmetric, as we can already see. So first of all, we will simply ignore this particular node. We are not going to deal with this. We will send these two nodes on the DFS calls. So first we can check whether these two nodes are equal in value. Yes, they are. So we can say that we have a symmetric tree till now. Now we will simply go to the next branch. I will take the left node of left subtree. I see it is none. And then I will take the right node of right subtree. I see there is some node here. So as you can see that I found this particular situation where I have a none node here and I have some node here. So I know at this point I have found a structural deformity. The structure is not the same. So I will simply say, okay, it is not a symmetric tree. I will simply return false. Now in case the 3 did not exist here we had none. Somehow, suppose we had none. Then I will simply go back here. Then I will go back from here also. We cannot say whether this tree is symmetric or not till now. Then I will go to this branch, right? I found this particular node, the right node of left subtree. And here I will be accessing the left node of right subtree. I see this is none. So I again found a structural deformity, right? I have a node here, I have no node here. So I can say it is false again. So we have figured out our base cases. If the value is not equal, we can simply say false. This is not a symmetric tree. If one of the nodes is none, one of the nodes, not both, then we can also say it is false. Let's go through the code now. First of all, we have res variable equals to true. It is the result of our function. We will set it to false if we ever encounter a condition where we can definitely say that the tree is not symmetric. Now we have our DFS function. First of all, we are declaring that we are going to use a res variable which is non-local. It is a global variable. Now we have a few base cases. In this base case, what we are saying is that if somehow we have already set the res as false, we can simply return. We know that the tree is not symmetric, so we don't need to process any further branches. It's basically an early return statement that will help you avoid extra computation. Now here are the main base cases. If both the nodes are none, we can simply return. We don't have to set res equals to false because this is a perfectly valid condition for having a symmetric tree, as we have already seen in the explanation. Now in case one of the node is none, we know that we have found some structural deformity, so we can simply say res equals to false because we know at this point that yes, it is not a symmetric tree, and then return. Now once we set the res false, we know that for all other DFS calls, this particular line will execute and we will early return. So this is how we save computation power. Here we are checking whether the values of the two nodes is same or not. We know that if they are not same, the tree is not symmetric. So I'm setting the res equals to false and returning from here. Now if all the base cases are fine, then we will go deeper. We will first take the left node of the left subtree and right node of the right subtree and go in that branch till the end, and then we will take the right node of left subtree and left node of right subtree and go for that branch. This is basically the coming back and going to the next branch logic here. Now here I'm calling the DFS for the left node and the right node of this base root, because we are not supposed to check the base root, it is going to be single anyways. Once the entire DFS completes, we know whether the tree is symmetric or not, so we simply return the result variable. Now let us run it and see what happens. Yeah, so it works. Our solution works in 0 milliseconds. It does not take any time. Wow. And it beats 100% of the solutions available on Leetcode. Great. Now we can discuss the time complexities and space complexities for this solution. The time complexity and space complexity is order of n. Technically, you can say that they are order of n by 2 because here we are taking two nodes from the tree at the same time in a single DFS call. So yeah, the DFS will run at most like n by 2 times, but we know that order of n by 2 is basically going to be order of n because we remove any constants, and here the constant is 1 by 2 multiplied by n. So we will simply ignore 1 by 2 and we will only take n. That's why we have order of n time complexity. Similarly for order of space, even though we are going to have n by 2 DFS calls, which means we will be using the same n by 2 space for the call stack in the auxiliary space, but then again this 1 by 2 will be ignored and we will have order of n. So yeah, like the video, subscribe the channel. If you have some kind of question that you would like me to target, if you have some kind of topic that you would like me to talk about, then just let me know in the comments, and now we will meet in the next video. Till then, bye.